So this is my second PSY157 lecture, and today we're going to be looking at the first of those commonly held misbeliefs that was on the quiz that I gave you last week. And this is the idea that we only use 10% of our brain. Last week I showed you this advert for a hard disk drive, and the reason I showed you this was to show you that the myth actually is in common currency in the world, and that advertisers use it as a foot in the door to convince you of the rest of their statement, that your hard disk should be a bit more efficient than that, so you need to buy a hard disk from them. That's not the only example I found. Here's another one from a major employer seeking to employ graduates. So this is a recruitment campaign for Shell, and you can see here they're trying to recruit people, and they start off by insulting them. You only use 10% of your brain. Plenty of scope for exploration. Make a difference. So they're using it in rather a clever way here, because they're looking in this advert, it's targeted at geologists and people who are going to discover mineral resources under the seabed. Plenty of scope for exploration in the world, and also inside your head. So you can make a difference. But again, they're using that catch line, you only use 10% of your brain, because they know people believe it. And here's a page, apparently, from a psychology website, Psychology Today. How to train your brain. In our imaginations, we fancy ourselves possessors of the wit and skill and repartee of a Robin Williams, until we stand tongue-tied over cocktails. But it's not entirely a flight of fancy, it's entirely possible to think a little faster, a little smarter, a little wittier. It's not all that difficult, insists Joel Saltzman, author of Shape That Brain. Conventional wisdom holds that we use a mere 10% of our brain cells. Why not put the rest of your head into gear? So this is another use of that common myth, 10%. But here it's being used directly to sell a self-help book. Remember, I argued that some of these beliefs, we tend to hold them because they excuse our poor performance. They hold out the hope we can improve ourselves. And here's a direct example of this. And in fact, although this is called Psychology Today, this website, it's not a real psychology journal or a peer-reviewed scholarly source that you would use in your essays. If we look at the left-hand side, the menu for all the other sorts of things you can find on this website, you'll see it's entirely devoted to self-help, to selling things to people. The topics are addiction, anxiety, depression, food and drink, parenting, sex, stress, work. And then they've got complementary health things. So almost any problem anyone types into Google, this will come up. And they can then sell you massage therapy, homeopathy, acupuncture. Here's the data that I've collected over the years I've been delivering this lecture, including you. Nearly 2,000, 1,889 people, and 61% of people said yes or maybe yes to this question, that we only use 10% of our brain. 61%. Now, can it possibly be true? Here's a very old graph. And this graph plots the brain weight in grams of lots of different animals on the vertical axis against their body weight in kilograms on the horizontal axis. So at the bottom left, we've got very small animals like a goldfish, a hummingbird, or a mole. also a vampire bat. And then as you move up to the right-hand side, we've got enormous animals, blue whales and elephants. So what this is plotting, this scatter plot, all of these points, the circles and triangles on this graph, represent different species. And you can see that if you're a small animal, you've got a small brain. And if you're a big animal, the dots go up to the top, you've got a bigger brain. Well, that makes sense. You've got a bigger body, a bigger head, more size for the brain. In fact, what the black line shows, that's called a regression line, and it shows the line of best fit through all of those dots. It's linear. There's a one-to-one relationship in general across all animals for the size of the brain compared to the size of the body. The ratio is pretty fixed. So you can see that most of the dots are quite close to that line. What's interesting is where the dots go further away from the line. So for example, the eel. Now the eel, it's not the subject of a Douglas Adams book, you know, So Long and Thanks for All the Fish, not renowned to be sparkling and witty at parties. In fact, for its body weight, it ought to be twice as high on that graph. It should have a brain of around 10 grams. In fact, it's got a brain of around 1 gram. So it only has a brain the 10th the size you'd expect from this regression line. It's even dimmer than your average animal. The same thing for Latinaria. It's below the line. Any dot below the line has got a smaller brain than you'd expect. Alligators, ostriches, and goldfish. Now you'll notice something about that. They're all fish or different sorts of birds or reptiles. If we now move above the line, you've got animals whose brains are bigger compared to their body size than you'd expect. So you can actually see that a crow is a cleverer bird. Its brain is bigger than you'd expect from the size of its body. And they are renowned to be one of the cleverest birds, the corvid family in general. They use tools. Some people think they're talking to each other and problem solving. And if we move up to the top right, as the body size gets bigger, the dot that's furthest above the line up there is modern man, quite close to porpoise, which is the topic of that Douglas Adams book. So their brains are much bigger than we'd expect. And in fact, I think I can draw the intersecting lines on here. There's modern man. You see where this line crosses, our brains are big enough. Sorry, that's our body weight here. It's about 70, 80 kilos. And our brain is just over 1.5 kilos, 1.6 kilos, according to that scatter plot. So you can see we're above the line. If we drop the line down, this shows us how heavy our brain ought to be given the size of our body. And it's about 160 grams. In fact, that is 10% of our brain. So here's a germ of truth in that myth. Our brains ought to be just 10% of the size that they are for our body weight. So if we just wanted to be as clever as the other animals, if we just wanted to control our movement, and our kin group maybe do a bit of hunting, reproduce, escape from predators, we only need a brain of 160 grams, 10% of what we've got. So if you are just using 10% of your brain, maybe that's your life. If we look at this graph the other way and say, okay, we've got a brain that's 1.6 kilos, how big a body would that serve? We can drop the line down and see that we could have bodies that weigh slightly over 1 ton. So, when you see a fully laden SUV hurtling towards you with a driver in it, his brain or her brain is just the right size to control that SUV if it was his body. Maybe that's why we've evolved brains this big.